Alrighty, welcome back, boys and girls. It's your main math man, Ms. Shank, coming to you live from Alameda International High School. In this video, we're just going through some review before the next assessment. So, on this first one, we're working with some sequence word problems, and specifically, we have this sequence. So, in general, our geometric sequences. So we're going to say UN is equal to, and we have the first term, which is U1, times the common ratio to the power n minus 1. So we're going to use that for this problem, but we have to be careful since we are seeing a percent, and we're going to be using a couple of these values. So it says you have $5,000 in a savings account where the value increases by 4% each year. How much money will you have saved up in 8 years? So we're going to say this. We're going to say U1, our first term, meaning what we start with in our account is going to be 5,000. We're going to say the common ratio R is going to be 1 plus, since we're using that word increase, we're going to say 1 plus, and then we're going to have this decimal this percent as a decimal. So I need to change this into a decimal, so I take 4 divided by 100, since it's 4%, and so I'm going to say it's 0.04, which means the value for R, the common ratio, is going to be 1.04. So we have this as our general sequence, and so what I can do is I can take these values and substitute them in. So I'm going to say UN is equal to, I have 5,000 times, and then 1.04 to the power n minus 1. So this is going to be our general sequence for this savings account, but it's saying how much will you have in 8 years. So you let n equal 8, and so what I can do is I can plug 8 in to our formula. So I can type it in exactly as it looks. I can say 5,000, and I can say times 1.04, and I have to the power 8 minus 1. Hit enter to get your value. So we're going to round that nearest hundredths because we're talking about money, so we're going to round it to that second decimal place. So I'm going to say after 8 years, so we're going to say U8 is going to be equal to $6,579.66. For that next set, so anytime I have some right triangles, I always want to write these big letters first. So I have SOHCAHTOA. The reason why I have this is because these are my trig ratios that I need to use for any of these right triangles. So it says for A and B, we're going to solve for the missing side, and then for the next two, we're going to solve for the missing angle. So let's go ahead and go through these steps. So I'm going to first do my labels. So I label my triangle first. So I have the side opposite of the right angle is going to be my hypotenuse. I have my angle theta, which is 32 degrees, is going to be side opposite of that is called opposite, and the side next to that angle, 32, is going to be our adjacent side. So I have those 3 labels. Now I pick my ratio, and how do I do that? Well, I'm saying, okay, I have O and A because I have 13 and X, and so that means I'm going to use a tangent for this. So I need to have tangent of theta is equal to O over A. I substitute in, so I sub in my values. I'm going to say the tangent of 32 degrees is equal to, I have O as X, and I have A as 13. When I go to solve, again, always multiply both sides by the denominator when you're solving for that missing side. So since we're not solving for theta, we can just solve for X. So we're going to multiply both sides by 13. So I have 13 times the tangent of 32 is going to be equal to X. Again, always multiply both sides by that denominator. So if you needed to multiply, you can. And we can say, all right, in a calculator, make sure it's in degrees. We're gonna say 13, tangent of 32, hit enter, and we have our value. So we're gonna say it's gonna be about 8.12. And for the next one, same steps, we're going to label. So I'm gonna say side opposite right angle is our hypotenuse. We have our angle theta, which is 37. Side opposite of that is called opposite, and we have adjacent, which is 11. So I'm gonna pick my ratio. I have AH, which means I'm going to use cosine. So I say cosine of theta is equal to adjacent over hypotenuse. Substitute in our values for our variables. So we're gonna have cosine of 37 is equal to 11 over x. Again, we said a is 11 and x is h. So now, since my variable is in the denominator, I'm gonna have two steps. Very simple still. Again, multiply both sides by x. So I have x cosine of 37 is equal to 11. Again, we have 11 on the right side because we multiplied both sides by x. Last step, we have to get x by itself, so we divide both sides by cosine 37, divide by cosine 37. So we're gonna say x is equal to 11 divided by cosine of 37, which is equal to, let's find out. So we have 11 divided by the cosine of 37. So we're gonna have 13.77. All right, in the next one, so let me see if I can squeeze this over just a little bit. There we go. So now in the next one, we're now solving for that missing angle. So this is where, so if you have that missing angle, this is when you use those inverse trig functions. So this is when we have those trig functions, but they are to the -1 power. So again, to do that, you do second and then whatever your function is. So if I need the inverse of sine, I hit second sine, and the inverse of cosine, I hit second cosine. See how it has a -1 in the exponent. Okay. Same steps as before though. When I go to solve for my triangle, again, I can label the sides. So I have my right angle, opposite of that right angle is the hypotenuse. I have my angle theta, opposite of the angle theta is called opposite, and we're gonna say 10 is gonna be our adjacent side. So that means this, I have O and A, and so I'm going to choose sine for this one, or sorry, yeah, let's take it back. I have OA, and so I'm going to say tangent. This is why I always write these down first, because I still make mistakes. It's okay, that makes us human. So I'm gonna say I have OA, so I'm going to use tangent. So I'm gonna say, all right, tangent of theta is equal to O divided by A. Substitute in your values for your variables. Since we're solving for theta, we have to leave it by itself. So we're gonna say tangent of theta, which is what we're solving for theta. We have O as 11.9, and we have A as 10. Again, be careful. I've seen a lot of mistakes when people are moving from this step to the next. Just make sure you are substituting in those values correctly. Again, make sure you're in degrees to get those answers correct as well. Here's the key step. Since we're solving for the angle amount, that's when we have to use the inverse of tangent. So we're going to say theta is going to be equal to tangent to the -1 power, and we have 11.9 divided by 10. So in your calculator, I hit second tangent. Still keep that same ratio, so I have 11.9 divided by 10. Hit enter, and now we have our amount in degrees. So I can say this is going to be equal to, let's still go out to that second decimal place, keep it simple. We have 49 point and then 96 degrees. So since we're talking about that angle amount, it is in degrees. If we're talking about side length, it would be whatever units the side length is. More specifically, if we're using solving for a side length, it's not in degrees. If we are looking for a missing angle, it is in degrees. All right. And then for this last triangle, one on the front, you can label your sides of H. Angle theta, opposite of that is called opposite, and we're going to say A is going to be 14. Still going to use our, let's say, tangent. So I'm going to have tangent theta is equal to O divided by A. So that means this, I'm going to say tangent of theta is equal to 7.7 divided by 14. Take the inverse of both sides, so we say tangent to -1 power of, actually, let's back up here. Let's say I have theta is equal to the tangent to the -1 power, and then we have 7.7 divided by 14. You can type that in your calculator. I have second tan, and then we have 7.7 divided by 14. Hit enter, get my amount in degrees. So let's see what that's going to be. So that's going to say about 28.81 degrees. All right. So now moving to the back, still working with some wonderful right triangles. Let's make sure we can set these up correctly. So again, follow these steps, draw the picture, label the sides, ratio, sub, and solve just like before. All right, so it says Morgan is standing 400 meters away from a building. The angle of elevation to the top of building is 63.4 degrees. How tall is the building? So again, we have a right triangle, so if you're ever unsure, just start with that right triangle. Again, you can always redraw it as many times as you need, as long as you are making sure it's a right triangle. So we say that is going to be 90 degrees. We're going to say, this is us right here, or excuse me, not us. This is Morgan down here. Nice to meet you. They're standing, 400 meters away. So 400 meters away from the building. So we're saying this is, your building here. This angle that we're looking up, since we're talking about elevation, we're looking up, so it's 63.4 degrees. Again, the angle of elevation is inside that right triangle. However, the angle of depression is outside, but you can draw it two different ways, which you'll see in just a second. So we say, all right, we have this as our variable x, since we're looking for how tall the building is. So that means when we go to label our right triangle, we're going to say, all right, this is going to be h. We have our angle theta. Opposite of that is O. And we have our adjacent sides. So still going to use tangent. Get used to using that a lot. So we have tangent of theta is equal to O divided by A. We have tangent of 63.4 degrees is equal to x divided by 400. Only one step, still the same. Multiply both sides by the denominator. So we're going to say we have 400 times the tangent of 63.4 degrees is equal to x. Let's type that in. So we have 400 tangent of 63.4. And so we're going to say this is equal to, let's have 798.78 meters. So that's a decently tall building. It makes sense too, since we're looking at a pretty solid amount. We're looking up at a 63-degree angle, which is pretty far, and we're also 400 meters away, so that makes perfectly fair sense. All right. And for that second part, again, be careful when you're setting these up. Always draw that picture out first. So I have a person is standing on top of a cliff looking at the ocean. The person spots a boat on the ocean, and the angle of depression to the boat was 13 degrees. If the cliff was 120 feet high, then how far is the boat from the base of the cliff? So Again, you can draw it two different ways. So I'll draw it like this. I'll say this is two different ways. If you need to solve it like this, again, I want to give you guys options. So if you want to use this angle 13 degrees, if you want to draw it like that, then you have to be very careful. So let's say if this is, let's say this is someone out here looking down at this boat. Again, you can kind of picture this as being where the cliff is at. We're saying the cliff is 120. Let's actually make it over here. We're saying the cliff is 120 feet, or yeah, 120 feet high. They're looking down at 13 degrees. So we're gonna say this angle here is 13 degrees. And it's asking, okay, it's talking about this side length. How far is it away from that base? So we can say this is going to be that side X. So if you want to use that 13 degrees, use it like this, set up your right triangle like that. If you want to have the normal looking picture, meaning this other triangle, I can say, all right, I can draw it like this. I can have still looking at that same boat. I'm saying persons, they looked down at 13 degrees, which means that this angle remaining is going to be 90 minus 13, which is going to be 77. So this is going to be 77 degrees. We said the cliff is still 120 feet, and we're looking for how far. So if this is the cliff right here, we're saying it's 120 feet tall, and we're looking for how far away the boat is from the base of this cliff, where that's your right triangle. So again, both of these should work, and I can prove them in just a second. So if you use that triangle, the first one, I can say I have, let's say this is hypotenuse. It's probably gonna still use tangent. So yeah, we're gonna have side opposite O is 120. We have our adjacent side is A. And so I have tangent of 13 degrees is gonna be O divided by A. So we have 120 divided by X. So that means that this is gonna be, I multiply both sides by X and then divide both sides by tangent. So I can say X equals 120 divided by tangent of 13. That's also, this answer should be the same as this setup. So if I say this is H, I have my angle theta is 77. I say that's the side opposite, and this is going to be adjacent. So if I said the tangent of 77 degrees is equal to X divided by 120, I should say X is equal to 120 times the tangent of 77. So hopefully these two match up, as I have confidence in them. So let's do this one first. 120 divided by the tangent of 13 is that value, and then we have 120 times the tangent of 77. Holy smokes. So always have faith and confidence in yourself. I'll be able to prove why that answer is correct, but I can say I have X is going to be equal to, since notice how it's still the same, even though it looks like it's different, we know these two sides are going to be the same. So we have X is going to be 519.78 meters, or let's say, sorry, it was feet. All right, moving on quickly so that way we can get through this. Last concept, graphing those wonderful trig functions. So first step is this. I want to say, what is my amplitude? A, which is that leading coefficient. So we're going to say this is 1. We're going to say our value of B is attached to our variable theta or x, so we're going to say it's 4. To be able to solve for your period, we say period is equal to, we say period is equal to 360 divided by b. So we have, this is equal to 360 divided by 4, which is 90 degrees. So that means that I'm going to have a period, so it's going to repeat itself 4 times. So again, this is the number of peaks from 0 to 360. And so that means from 0 to 90, I'm going to have those 5 points. Okay, since we're working with sine, I know that I have to start at 0. So wherever I start at, I have to end. So again, sine starts at 0. So that means we end at 0 as well. So between 0 and 90, I'm going to have my 5 points. So that means I have to go use our amplitude. I have these values. So what I can do to figure out my next values, you can draw that circle, or you can do this. I can say, okay, I can take my period. I can say 90 divided by 4 to figure out what my 4 other points are going to be after 0. So that means at 22.5 degrees, I go up to 1. So that's going to be now going down. At 45, I have 0. At 67.5, I have -1. And then at 90, I have 0. So after that, it will repeat itself. So I go up to 111. And then let's say it would be 112, because it would be 90 plus our answer. So all I'm doing, this would be 112. And then we'd say this plus another 2.25, 135, okay, yeah. Down to -1, and then 0 at 180. And so we can kind of notice how it is repeating itself every time. So again, I have a full cycle between those steps of 90 degrees, and so that's how we get those 1, 2, 3, 4 peaks. Again, from 0 to 360, we have those 4 peaks. Always double check your answer. So I can say I have sine of 4x, hit enter. Make sure your window is set to those values. Again, make sure your window is set to those values. Hit graph. Notice how it's not that tall of a function. It's between 1 and -1, but we have those 4 peaks and we are good. Again, if you need to see the table of values, be sure you can set it up, and I can say, all right, let's do second table set. I want to have it changing by 22.5, because that's the amount of change, or each time those points are made. So it's second table, and now I have my values like so. And for this last one, I can let's identify A. So that's 4. So I go up to 4, down to -4. Our value for B is going to be 2. So that means our period still 360 divided by B. But for this one, we're going to say it's 360 divided by 2, which is 180. So that means from 0 to 180, we have those 5 points. And that also means our number of peaks is 2. So from 0 to 360, we have 2 peaks. All right. So if you're wondering where those 4 points are going to be, so I have 180 divided by 4 to get those values. So that means that every 45 degrees on our x-axis, I'm going to plot another point. So I'm going to say, okay, cosine starts at 1. 1 times 4 is 4. So I have to start up here at y equals 4, and now I have to go down. So at 45 degrees, I have 0. At 90 degrees, I'm going to have -4. At 135, I have 0 again, and then at 180, I have +4 as well. So you can notice how I have those 5 points from 0 to 180, and then I can start repeating myself. So I have 225, 270, 315, and 360. So from 0 to 360, I have those 2 peaks. Always double check, so I can say I have 4 cosine of 2x. Let's set our table to change every 45 degrees. I can hit graph, and so notice how it goes down to -4 and up to +4. And we have those 2 peaks from 0 to 360. And if I have the table of values, again, starting at 0, I have 4. I go to 0 at 45, -4, 0, +4, and I repeat myself. So again, make sure you can set those up carefully for yourself. Ask questions as needed, and as always, super slam that subscribe button.